Okay guys, so we're going to start reviewing energy, and our first part of our standard has to deal with potential energy and kinetic energy and how they're related to mass and speed and height and mass. So this is when we were talking about roller coasters and we did pendulums. All of these things are going to talk about potential and kinetic energy. So remember that when we have stored energy, it's dealing with its position or shape, like this spring, and this is the potential energy that we're talking about. The position of this rock being so high up means it has a large potential energy. It has the potential to fall a great distance. Same with this spring, it's dealing with its shape. When we compress the spring, it has the potential to then move if we release it. Okay, and this is in our song. If you remember, potential is stored energy. So it reminds us that the stored energy is our potential energy. Okay, so in this roller coaster, where is there the most potential energy? So take a second and try to answer it. Okay, so our most potential energy is going to be up here at number 1 because it has the largest height. And then our next height is going to be number 3, so that's going to have the second most potential energy. And then 5 will have the third most potential energy. And 2, 4, and 6 are kind of all tied for the least potential energy because they are the lowest height on the roller coaster. And this is also in our song. So it's right here when we have mass and height affect so clearly. So mass and height are going to affect the potential energy, and what we were just looking at was dealing with height. And says we're talking vertical. The higher in the air you go, the more potential starts to grow. So the higher in the air, the more potential energy is what that's saying. So the higher we are up here, the more potential. Okay, then we also have kinetic energy, which is in our second verse of that song. So kinetic, moving energy, and it's also sometimes referred to as mechanical, called mechanical, don't you see? So this is when we're dealing with moving energy. So in our pendulum, or we could think about this on our roller coaster too, but for the pendulum, our total energy is going to equal all of the potential energy and all the kinetic energy put together. So when we're at the highest point with our pendulum, it has the highest potential energy. So 100% of the energy, all of the energy is coming from potential because it's high off the ground and it's not moving yet. Therefore the kinetic energy is 0%. There's no potential energy. So this is up here when the pendulum is the highest, we have the maximum potential energy. And then as it swings, it starts to lose that potential energy because it's no longer as high, and it turns it into kinetic energy because it's starting to move. So at this point, we have half potential energy and half kinetic energy because the total has to equal 100%. And then as we move down here, we are now at the lowest position, which means our potential energy is 0 and our kinetic energy is 100%. And if you remember when we did the pendulum in the classroom, that the pendulum actually moves faster when it's at the bottom of the swing, which means its kinetic energy is the highest. So take a second and try to guess what these two, so we can do an answer for number 1 here. Let's see if I can get my number in the right spot. Number 1 and spot number 2. Okay, so here again we have 50% kinetic energy, 50% potential energy, and then up here at the top we have our maximum potential, so we're going to have 100% potential energy and 0% kinetic energy. Okay, so the higher our sled is, the faster you will go. Why is this? This is dealing with our potential energy getting turned into kinetic energy. So the higher our potential energy, the higher up the sled is, means it will turn into and generate more kinetic energy. This is why we want our roller coaster to be really high at the beginning, because that potential energy will then turn into kinetic energy so that it can go over hills and loops and whatnot. Okay, so if you remember, we also have to look at graphs with potential and kinetic energy. So here, which graph best represents the relationship between kinetic energy of a moving object and its velocity? So this one is actually going to be number 3. And the reason is it's dealing with kinetic energy, and that's the one where it's going to curve up and to the right. And this is in our song. The only time that we have a energy graph that curves is when it's kinetic energy and velocity. Because if you remember from our song potential energy, the graph is always going to be straight, and it says it in the song. The graph is as straight as can be. So the graph's always straight for potential energy. So that would be like this example. If we plug in our equation for if we keep mass the same, gravity the same, and we're increasing the height, we get different numbers, so that we will have a graph that is straight, and it goes through the origin. So every single time we have potential energy, it's going to be straight like this. But kinetic energy is dealing with mass and velocity, and it says the graph curves up and to the right when speeding up. Is that all right? Flat when speed is just sitting tight, or when it's standing still. So there's sometimes when kinetic energy is flat and sometimes when it's speeding up. And the difference is it's going to be curved when it's speeding up. So that's dealing with our velocity. So here we have our velocity 1, 2, 3. So it's speeding up, and we're looking at kinetic energy. So because of how the equation is, it makes our an exponential curve is what's happening. So our points are going to be in a curved way. So at first we're going 5, then we're going to put a dot at 20, then we're going to put one at 45. So it's going to actually curve up kind of like this, and I didn't quite hit all the right spots. Oops. Oh, where did my slide go? There it goes. So it's going to curve up kind of like that. And again, that's because it's kinetic energy, and we're looking at the velocity increasing. But if we have kinetic energy and the velocity is the same and just the mass is increasing, it's actually going to, again, just have a straight line that goes through our origin. Okay, and that's our review for kinetic and potential energy.